All right, sorry for missing class today. I've been home and I just got back from the doctor, but I figured I'd make a quick video with the solution to the homework that's due today. The homework that's due on Friday deals with dictionaries, um, and I'll do a quick little code snippet at the end on dictionaries. I think you've read about it, and I think we've talked about it in class, but um, let's just see where it goes. But anyways, for the homework that was due today, or comma code, they're saying, what if you had a function that took in a list that looks kind of like this? All right, and what they want you to do is they want to take in a list like that and return, so not prints, but it returns a string with all those items separated by a comma. So we're building a string from the contents of this list. And what we're going to do is we're going to have each one separated by a comma and a space. So kind of like building a sentence-ish, with the very last one having an and before it. So for this one, it should be apples, comma, space bananas, comma, space tofu, comma, space, and space cats. So that's what we're trying to accomplish. So we're looking at the various patterns we've done up to this point. We're going to go through every element of the list. As long as we're not the very last element, we're going to be building up a string through concatenation. And if we're at the very last element, we're going to build that string up just a little bit differently and then ultimately return it. All right, so let's look at this. Let's see, do I have... All right, so I'll just do it down here near the bottom. So we'll def comma code, and this guy's going to take a list in as a parameter. And again, like we mentioned last time, I've seen some people have asked some questions. They, right at the very beginning of this, they said a list equal to, you know, A, B, C, whatever. You do not set the value for a list. Somebody else is going to call comma code. So for instance, I might call comma code down here, passing it this variable a I defined here. And that means that that a list will be equal to the contents of a. Similarly, on the very next line, I can say comma code and pass it b. So a list has to function generically because we want to support this function taking various inputs and being able to operate on those inputs. All right, so here's two examples of comma code being called with two different inputs. So if I want this guy to be able to take two different inputs, the last thing I want to do is immediately overwrite whatever my input is with something new. Okay, so if you find yourself changing the value of the parameter coming in, pretty good chance you're doing it wrong. All right, this guy is the value that was passed to this function in order for this to work. All right, so we're inside here. We're going to be building up a string, so maybe we'll call that guy answer. And we're going to have our common loop that's going to go through every single element of our list. So maybe for I in range, 0 to length of a list. So this is our common this is our common for loop. Now, we want to do the same thing every single time unless I is the very last pass through the loop. Now, we could do a couple different things here. We can choose to loop through one fewer than the last thing in the loop, last thing in our list. And then after the loop is done, we can do our special case with the and. Or we can ask some questions inside the loop. I'm going to go ahead and just loop through one short of our last element. All right, so this is by our example down here. If we were passing a in, this will go through cat and dog, but not elephant. Elephant will handle post for loop. Okay, so for these guys, we're going to say answer is equal to answer concatenated with whatever our current value is, which is a list at position I, concatenated with a space and a comma. All right, so we're going to build up answer like that. So when all is said and done, we should have our, by our example here, we should have cat space comma dog space comma. Okay, that's the last one we'll have. So now when we're out here, answer is waiting for the and whatever the last thing is. So we'll say answer is equal to answer concatenated with a space followed by the word and followed by a space concatenated with the last thing in our list, which is a list at bucket length a list minus 1. That's the last legal element in our list. Now, I know there's some shortcuts for getting to the last element, but I think this is perfectly reasonable. I want a list. I want the position of a list that is equal to the length of a list minus 1. So don't use shortcuts until you're very confident with these things. All right, and then we've built up our string, so we will return that string. And we'll go ahead and test this. And comma code returns a value. If I want to print that value, I have to either store it in a variable or I can just print it directly. So if I go ahead and run this guy, there's my cat, dog, and elephant. All right. So I think that should get you through the assignment that was due today. Now let me just give you a quick, refresher on dictionaries. So now a dictionary is a collection of name-value pairs where we do not necessarily get to benefit from order. So a dictionary does not dictate what was the first thing put in there, what was the second thing put in there, what was the third thing put in there. All right, we don't get those values. So just to kind of set us up for what we might look at on class on Friday, let's assume I want to create a dictionary that goes through all of the characters, that kind of provides us the mapping. Actually, we'll do it fairly simple here. So let's say we're going to just convert this list into 3 animals where we have an animal 1, an animal 2, and an animal 3. So I'll go ahead and create a dictionary. I'll just name that variable dictionary. And notice that dictionaries use opening and closing curly braces. All right, and I'll go ahead and write a loop. So for I in range 0 to length of A, for example. And each time through, I'll say a dictionary at bucket. Now, I give this guy a key, not an index. So a dictionary is a bunch of name-value pairs. So the key is kind of like a variable name that we're going to associate with the variable, or with a value. So I might say animal, I'll put a little space here, and I'll concatenate onto that the string value of I. So this will boil down to animal 0, animal 1, animal 2, so on and so forth. I'll say that guy is equal to A at bucket I. Okay? And then if after that I print out a dictionary, we see that I have animal 0, animal 1, animal 2 are all matched up to cat, dog, and elephant. So if I want to print out a dictionary at position animal 1, for example, I would get dog from that. Isn't that what it is called? is it not liking about that? I have to be spelling something funny. That's the empty dictionary. Oh, parenthesis. Square bracket, just like our lists. So there's our dog. All right, so now something a little bit more practical that we've been looking at in class. Maybe we create a dictionary called hex mapper. And hex mapper is equal to, we'll start off as an empty dictionary, and we'll say hex mapper at position A is a 10. Position B is an 11, so on and so forth. So now if I'm doing our number conversion stuff like we've been doing in class, I can do something like hex mapper at bucket A, and it would go ahead and boil down to that numeric value of 10 for me. So it does that mapping for me to go from A to 10, and similarly we can go from 10 to A. All right, so kind of gives you a use for dictionaries there, and you'll be using dictionaries for the homework due on Friday. So in any case, I will put this this code up for you to look at on Slack, and I'll post this video, and hopefully I will be back to class on Friday.